Imagine a computer that remembers the past to understand the future. Unlike standard networks that treat every input as an isolated event, recurrent neural networks are specifically designed to process sequential data, like text and speech, where order is everything. Let's start by contrasting this with feedforward neural networks, which process inputs independently. In those systems, the order of elements doesn't matter because there are no connections that loop back. However, for tasks like analyzing a sentence or stock prices, context from previous steps is absolutely critical. This is where the unique architecture of RNNs comes into play. They utilize recurrent connections, meaning the output of a neuron at one specific time step is fed back. Input to the network for the next step. This creates a loop that allows information to flow through time. By using this internal feedback loop, RNNs maintain an internal state, effectively acting as a memory of previous inputs. This allows the network to retain context and history as it processes sequences, solving the fundamental problem that static networks cannot handle: dependent data. This capability makes them ideal for complex tasks where context matters immensely, such as natural language processing for translating sentences or predicting the next word in a story. The architecture has evolved from basic units to sophisticated variations like long short-term memory and gated recurrent units. Consequently, these models have played a crucial role in advancing artificial intelligence across various fields. They effectively handle time series data and audio recognition by ensuring that the sequence of events is preserved and analyzed correctly, rather than just looking at individual snapshots. In summary, RNNs are fundamentally designed to handle sequential data by using their internal state to remember past information. They transform how machines understand the flow of time in digital signals, bridging the gap between isolated inputs and continuous streams. Understanding these loops is key to grasping how AI learns from sequences. What other types of sequential data do you think will benefit most from RNNs? Let me know your thoughts in the comments below.